Problem 2-7. Your results from this problem will be useful in the parabola investigation that you will do in lesson 2.1.2. So in other words, this is one that you actually want to take seriously because it's going to come up again in the next section. So letter A, draw the graph of y equals the quantity of x minus 3 squared. If you are drawing the graph by hand, be sure to use the domain 0 to 6. Says, and then how is this graph different than the graph of y equals x squared? So rather than just doing it all on the calculator, I decided I was going to do this one by hand. They have given us the domain, which is nice. So we're going to take it and use that domain here. There's x, there's y. So they said they want us to go from 0 to 6. So let's plug them into our function to figure out what our outputs would be. So we're going to say y equals, the first one, we're going to say 0 minus 3 squared. Well, 0 minus 3 is negative 3. And negative 3 squared would give us 9. And if we do y equals 1 minus 3, and we square it, 1 minus 3 is negative 2. And negative 2 squared is going to be 4. Let's do 2. Y equals 2 minus 3 squared. 2 minus 3 is negative 1. And negative 1 squared is going to be 1. If we do 3, y equals 3 minus 3 squared. Well, that's 0 squared, which is 0. And now we're up to the other side. We've got 4 minus 3 squared. That's going to be 1. 1 squared is 1. And because we know that this is going to kind of grow at the same growth pattern as this side, we should get 4 when we plug in 5, and we should get 9 when we plug in 6. Let's plot these points on here. So remember, this is your x-axis, your y-axis. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're at 1, 4, so over 1, up 1, 2, 3, 4. 2, 1, so over 2, up 1. Over 3, up 0. And then we have that symmetry that happens with the parabola here. So we're looking at a parabola that looks like this. Oh, I missed. Hopefully you do better than I do. It's a lot harder to draw it on here. And just because I don't accept it when you do this, I need to make sure I fix my own. That's better. So we've got our parabola that's going up like that. So we have drawn what they asked us to draw. They said, how is this graph different from the graph y equals x squared? Well, if we graphed y equals x squared, I'm going to go ahead and just graph it here. Y equals x squared would have a table that would look like this. And I'm going to go ahead and go from negative 3, negative 2, negative 1, 0, 1, 2, and 3. So if we look here, when I plug in 0 into y equals x squared, I'm going to get 0. When I plug in 1, I'm going to get 1 squared is 1, 2 squared is 4, 3 squared is 9. Same thing here. Negative 1 times negative 1 is 1. Negative 2 times negative 2 is 4. And negative 3 times negative 3 is 9. If you look here, you should see that we have the same outputs. So if we plot them, we're going to have a point at 0, 0, 1, 1, 1, 2, 1, 2, 3, 4, and then over 3 up 9. Back 1 up 1, back 2 up 4, back 3 up 9. I'm just going to kind of dash this one in. So what has happened here says, how is this graph different than y equals x squared? Well, this graph, our red one, has been taken and we've shifted to the right 3 units, or it's been translated to the right 3 units. Every point is 3 units over to the right of the other ones. So to answer the question, this graph has been shifted or translated to the right 3 units. So as you think about it, you may want to start thinking about, where did that 3 come in? How did that 3 affect our parabola? And that's something we'll discuss as we move forward. But that's all we're looking for from 2-7. If you have questions, make sure you ask your teacher. Otherwise, thank you for watching.